Hello and welcome to another edition of Ontology Talk. I'm Adam Pease, and today I want to talk a bit more about automated theorem proving. As those of you who have been following my channel may have noticed, I haven't posted many videos in quite a while, mainly because I've been working fairly intensively on the development of a new theorem prover thanks to a lot of help from Professor Stefan Schultz. So today I want to talk a bit about how we go about testing theorem provers. So testing is absolutely essential, as any software developer knows, and it's especially important when you have a fairly complex system. And certainly theorem provers fall in that category. And so thanks to some work at University of Miami and University of Iowa, there's a great service called StarExec that is strictly for theorem proving testing. It's not a general purpose sort of cloud server environment. But if you need to test a theorem prover, it's possible you may be able to request access to this system. It is by approval only. And it's a fantastic resource because instead of testing on my laptop, I can instead be testing on a fairly high-powered server. And so I just wanted to detail a little bit of the process that I go through in doing this sort of testing. So the first step is obviously to log into the system, which I'll do now. I'm logged into the server at University of Miami. There are actually two server farms, one in Miami and one at University of Iowa. And I've already loaded the system with the TPTP test suite, actually two different versions. If you get a new account, you'll probably need to do the same unless you happen to have your own set of tests. And so you probably ask Professor Jeff Sutcliffe at University of Miami to give you permission to link to an existing copy. It's a very large system. I think it expands to something like 6 gigabytes of problems. That's why it's TPTP, thousands of problems about theorem proving. It really allows you to very comprehensively test a wide variety of theorem proving systems. So I've already loaded in, I got this link to the latest version, TPTP 4.0, and it consists of a lot of problems in different categories. So let's see, I think there are 54 different problem categories, everything from puzzles to reasoning about number theory, that's in the num category, the puzzles are in the PUZ category, and so on. And each one of these categories in turn has a lot of benchmarks. We can see the IGT category has 77 different benchmarks below it, ALG has 549, and so on. And then there's also sets of axioms, or these are sort of supporting theories that are common amongst many problems that get loaded like an include file, essentially, in normal programming. So let's take a look at how we go about doing some testing. So the first thing to do here is I'm going to click in this overall problem set, and I'm going to add a new solver. So we've got a sort of a status list here. So on the left, you get a directory structure of coming down from the root to users to your own particular user space, which you have access to, and you don't have access except in very limited ways to the other stuff in here. There's not really much to explore. And over in the right-hand pane, you get a little bit of status about what stuff is really active for your space. And also note on the right, you've got a little trash can for deleting things. So you can have jobs. These are tests that you start running. You have solvers. These are ATP systems, either things you've developed or maybe something that you're testing for some of your colleagues or running a comparison against. We have the actual benchmarks. Those are the things that we just took a look at that are in the problem spaces. There's one user. You can have multiple users that have access to a space. And then there are these subspaces. So it's really just reiterating the directory structure. It's a fairly, if I must say, a primitive interface, and it has some quirks to it. So I really only do a few things that are fairly well prescribed. There could be a lot of great work that volunteers could help out with, I think, in improving this interface. But for now, to do simple things that are straightforward that everybody does, let me show you how we do it. So first thing to do is to upload a solver. So I have a solver that is written in Java. And so first thing I'm going to do is I'm going to choose that. So let's go to my repository for JavaRes, the distribution area. It's a zip file, and I'll also do another video about how do you prepare a solver for this environment. I've already loaded this previously. I'm going to give it a name. So the standard format is the name of the prover, 3 dashes, and then a sort of traditional software numbering scheme. All the rest of the stuff you don't really need to worry about. So I'm just going to upload it. Okay, and it grabs the description from the zip file, gives me a little more information here. Okay, and that's good. So now we can go back to the spaces, which is really the directory hierarchy. All right, and we can see now here that I have one solver, Java Res, my new resolution theorem prover. And you have to actually load these things in the right directory. It's a little bit quirky. So actually I have to load things in the problem directory. There are many ways to load them, but you don't want to duplicate stuff. So you really want to take advantage of a facility that's maybe not all that clear at the start here, but is linking things in the space, very much like a symbolic link in many traditional operating systems. And to do this, I actually need to click and drag my prover into the problem space. I'm going to link it in the space hierarchy. Okay. It tells me that it's been moved successfully. And now if I look in any of these subspaces, you can see that the list of solvers shows my Java resolution theorem prover. It's in there. Okay. So now we're all set to actually start a job. So there are no jobs available right now. Let's create one with the create job link. Description here can be anything. Let's just call it test. You've got a few options in how you process things. The timeouts involved, pretty standard as a CPU timeout of 300 and a clock timeout of 600 seconds. So I don't really change those. I just stick with the standard. So that gives me comparability to other provers and prover runs of provers, tests of provers. So let's click next. Now you do have the option, if you've already loaded lots of provers and maybe you just want to try some of those provers on some subset of the problems, then you can go ahead and choose them. I'm just going to run on everything. Something you probably shouldn't do terribly often. It's a lot of problems. There's something like, I think, 24,000 problems. And this does take a while and it loads the server, but if you want a comprehensive picture of how your prover does, this is the way to do it. So it's just now going to run Java Res over every single problem in the space and let me know how it does. And this is going to take some time. So I'm going to submit it. It takes a minute to set it up here. Okay, and now if we go back and we click in the space, we've got to re-expand the hierarchy. We look at our jobs, right, and we can see that it's incomplete. There's 23,291 problems that are going to get tested, and it's going to show us how many are complete, how many are failed. When it was started, it'll finally tell us it's complete when it's done. And when it is done, it's got a tiny icon here with a square with an arrow in it that we'll be able to click on to get the results. So I'm going to take a brief break in the video and we'll check back when we're done.